Right. Look, my dear student, here this is second video of class 9th. We are looking here sound. What is their characteristics? Look here, flow chart of types of waves. Flow chart of types of waves. How many types of waves you are thinking in your mind? So types of waves are two here. Depending upon the movement of particles, wave, it is nothing but a vibration through wave. It is nothing but vibration through. Look how through medium. Wave is a vibration through medium. Here mechanical waves are there and electromagnetic waves are there. Already I shown the differences. Electromagnetic wave can use medium as well as vacuum, but mechanical wave can go through medium only, either gas, solid and liquid, but not vacuum. It is fail. Next examples also I have given morning. Waves. Look there. Wave is two types. One transverse wave, one longitudinal waves. Transverse waves, it is go up, come down. Two. From rest position, go up, come down. Go up, come down. So this is a transverse wave. Vibrates up, down, up, down, up, down. Go up and come down. Next here, one particle go right side, come left side from rest position. I mean it is called to and fro. Front, back is called to and fro. And what is next here? That is important. Look here. Sound is a longitudinal wave. Please keep it in your mind. Sound is a longitudinal wave. When we are speaking about sound is a longitudinal wave. It is confirmed. After that, what given? Based on method of propagation of waves. Are two types. What are the types? One longitudinal waves, second one transverse waves. What is longitudinal wave? Longitudinal wave, it is that wave in which particles vibrate to and fro. Longitudinal wave, to and fro. Their nature I drawn here. Look here. Here compressions, very near fractions are there, very near waves are there. Here waves are little gap maintaining, here waves are again very near. Compression mean near and near. I mean this is amplitude na. Pen spring, have you seen tick-tock pen? In the tick-tock pen, this, for example, when you are feeling spring, compressions mean waves are very near, very close, and rare fractions mean waves are very long, distance maintained. Look here, this is called wavelength, compression to compression, nor rare fraction to rare fraction called one wavelength. And when you are looking here, displacement of air particle is best example. Displacement of air particle or molecule. Goes forward, comes backward. Goes this side, comes this side. To and fro. I drawn this picture only there. Look there. One longitudinal wave is equal to one rarefaction, one compression. Compression, rarefaction, like that. So longitudinal wave consists of compression and rarefaction, both are there. Longitudinal wave consists of compression and rarefaction, both are there. Anatomy of sound wave. Look here, anatomy of sound wave. What is that? Direction of wave propagation. Direction of wave propagation. How waves will form. Longitudinal wave I drawn there. Look here, clearly long distances. Distance is more. Distance is more. Here distance is very near. Again distance is more. Again distance is very near. Distance is more. Again distance is very near. When you are looking them, distance is near and more. Near and more there. Disturb मत कर रहा, वीडियो चल रहा है. So distance and near. When you are looking distanced places, we are calling rarefaction. Distanced places are called rarefaction, and near places are called compressions. Compression mean waves are very near. Rarefaction mean maintaining distance. Compressions are high pressurable. Look here, compressions are high pressurable and rarefactions are low pressurable. I can tell that one more point for you. Compressions are volume of compression is decreasing, density of compression is increasing, but volume of rarefaction is increasing, density of rarefaction is decreasing. Please keep that in your mind. That after, when we are looking transverse waves, what is transverse wave? Very clear definition is that transverse wave is that wave in which the particles vibrate up and down. Please keep it in your mind. When particles are vibrating up and down, already I drawn, this is up and this is down. When particle is moving up and coming down, that is called transverse wave example. So look here, I drawn already one wave. Very clearly it is up. Upside is called elevation wave, elevated wave, and it is called crest also be. Second point is that when down, the down is called trough and it is called depression. Down half is called depression wave or trough wave, and it is called upside is elevation or crest, and between of two crests distance is called wavelength. Two crest distance is called wavelength, or two troughs distance is called wavelength. One transverse wave is equals to one crest and one trough. This is compressions and rarefaction. One transverse wave is equal to one compression and one transverse trough. Any doubts there? You just call me to my WhatsApp number. Already you have. My number is there. Just send to my WhatsApp. Any doubts are there? You just send the question. I will make the videos and I will send you.